Hi guys, welcome to a lesson of partial differential equations. So we will take some more problems on Fourier transformations of partial differential equations. So let's start with a problem that says that ut equals complex times iaUxxx. So it's a third order partial differential equation, and we will see how to solve this equation. The domain of x is again from negative infinity to positive infinity, and given that the initial condition is a function of x. So now again, similarly, we can start solving this problem by applying the transformation on the given equation. So that will be f on ut equals f on iota a UXX and plus Fourier on UXX. All right, so the Fourier transformation of ut is nothing but it's du over dt, and then iota times a, it's constant, and Fourier of this function will be nothing but iota times omega cubed times u plus the Fourier of this thing will be negative omega squared times cu. All right, so it will be du over dt equals iota a times negative iota omega cube times cu minus omega squared u. Then we can write du over dt equals a omega cube times u minus omega squared u, right? So in this manner, we can solve this equation. So this is simply first order linear differential equation. So we can solve, and it's separable as well. So it's easy to solve this equation. We can take out u as common, and it will be a omega cube minus omega squared. So du over u equals a omega cube minus omega squared dt. So now the solution to this equation will be simply u equals a e to the power a omega cube minus omega squared t. All right, so this is the solution in terms of omega t, but we need the solution in terms of omega and x and t. To apply the Fourier transform on the initial condition, that is ux comma 0 equals some function of x. So it will be nothing but it will be some function of omega now after the transformation. Then we can simply plug in this condition here. So you'll get u of omega comma 0 equals a e to the power 0 equals phi of omega, which implies that a equals phi of omega. So now we can write u equals phi of omega times the exponential a omega cube minus omega squared times t. And then simply by applying the inverse transformation, you can get the function in terms of u omega t equals the inverse transform of phi of omega times e to the power a omega cube minus omega squared t. And this will be simply u of x comma t equals 1 over 2 pi integral negative infinity to positive infinity, this whole function a omega cube minus omega squared t times e to the power iota omega x d omega. So this is the solution for this equation. All right. So